So this is problem 23 of chapter 10 of Giancoli 6th edition. So the question is, what fraction of a piece of aluminum will be submerged when it floats in mercury? Okay, so remember, mercury is a liquid with a very high density, so even a piece of aluminum will float on it. Okay, and then we want to know what fraction of this piece will be submerged. Okay, so remember, how do we get an object to float? Well, here is the liquid, and if this object floats, that means that just part of it is submerged in water or in the liquid that we are studying. The other part is outside. So the buoyant force is being exerted only on this part that is inside the liquid. Okay, so we have the weight of the object, and we have the buoyant force equal to that weight. That's why the object is floating, and this buoyant force again is exerted only on this piece that is inside the liquid. Okay, so this is the equilibrium situation, so the buoyant force is equal to the weight of the object. Okay, what is the buoyant force? Is the weight of the fluid displaced, right? And this is equal to the weight of the object. I can cancel this G. What is the mass of the fluid that was displaced? Well, we remember the density is mass divided by the volume. So I can write this mass as the density of the fluid. In our case is mercury. Just look at the table. And volume, which volume? The volume of the fluid that was displaced, not the whole thing. Okay? And this is equal to the density of the object. In this case is aluminum, so you can check the density of aluminum on a table, multiplied by the whole volume of this object. Okay, so we want to find what is the volume that was displaced. Well, it's a fraction of the total volume of the object. And what is this fraction? The density of the object divided by the density of the fluid. Why is this object floating? Because the density of the fluid is larger than the density of the object. Okay? So here we have a fraction of the whole volume of the object. Okay? So that's how we get the result.